Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. For the last few weeks, you've been running down a one-way street. I give you a function, and you use your rules to find its derivative. But what if we need to turn around and go the other way? This reverse operation is called finding the antiderivative, and it's the foundation of integral calculus. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. Let's take a look at a pattern. We know that the derivative of x to the power of 3, so here our f of x is x to the power of 3, so the derivative f prime of x, that's going to be 3 times x squared. And similarly, the derivative of x squared is going to be 2 times x. Because the rule that we learned is that when we take the derivative of something that is x to the power of n, the power drops by 1. And then the original power gets pulled over to the front, and it is our coefficient. And this is why if we want to reverse this process to find the antiderivative, we have to do the exact opposite, which means instead of multiplying by the power and then decreasing the power by 1, we must add 1 to the power and then divide it by that new power, which is why if we want to get the function f of x back, we're going to increase the power by 1, which means that this is going to be x cubed. And then we're going to have our original 3 in front, but then we're going to divide it by that new power, which is divided by 3. And this is how we get back to x to the power of 3. Similar for g of x, the power increases by 1, and then we divide by the new power. So this is how we get x squared back. So now the general form of that is if f of x is equal to x to the power of n, then its antiderivative is going to be x to the power of n plus 1. Notice how we increase the power by 1. And then we divide it by the new power, which is n plus 1. But the important part here is that we have to have a plus c. And the c here is a constant. The reason is because when you take the derivative of a constant, it's always going to become 0. And one important thing here is that n cannot be equal to -1 because we cannot divide it by 0. So now this is what we call the general solution because we have the plus c, where c can be any number. And now let's take a look at a couple of examples. We want to find the general antiderivative of this function here. So using our formula from above, we would have capital F of x is equal to, we can pull the 3 to the front, and then the antiderivative of x to the power of 2 is going to be x to the power of 3 divided by 3. Plus, same thing, we're going to pull 4 out to the front, and the antiderivative of x is going to be x to the power of 2 over 2. And then finally, the derivative of -5 is going to be -5x. And now we have to add our constant c. So therefore, the general antiderivative is going to be x cubed plus 2x squared minus 5x plus c. And since this is our first example, let's just verify our answer by taking the derivative of again. So we would have f prime of x, which is just our lowercase f of x, that is going to be 3x squared plus 2 times 2, which is 4, times x minus 5, and then the derivative of a constant c is just 0. So as you can see, we got our original function back. So this would be the general antiderivative. Moving on to the next example, for this one, the first thing we need to do is rewrite this function so that the terms are in the form x to the power of n. So we get f of x is equal to x to the power of -3 plus x to the power of 1/2. And now we can use the formula from above to find the antiderivative. So we get capital F of x is equal to x to the power of -2 over -2 plus x to the power of 1/2 plus 1, that's going to be 3 over 2. And then we have, this is going to be over 3 over 2. and then we add our constant c. So that means the general antiderivative for this one is going to be negative 1/2 times x to the power of negative 2 plus 2 over 3 times x to the power of 3 over 2 plus c. Now for our last example, we want to find the antiderivative of this function here, but we're also given the additional piece of information that f of x passes through the point 2, 7. So we're going to start the same way. We start by finding the general antiderivative. So we get f of x is equal to 3 times x to the power of 3 over 3 minus 4 times x to the power of 2 over 2 plus 3 times x plus c. And then we're just going to simplify this a little bit. So this becomes x cubed minus 2x squared plus 3x plus c. So now that we have our general antiderivative, we can go ahead and use that point to find the particular solution. And how we do that is because it passes through the point 2, 7, that means f of 2 is going to be equal to 7, which means 7 is equal to 2 to the power of 3 minus 2 times 2 to the power of 2 plus 3 times 2 plus c. So we get 7 is equal to 8 minus 8 plus 6 plus c, which means c is equal to 1. So therefore, our final answer is going to be f of x is equal to x cubed minus 2x squared plus 3x plus 1. And now let's do a quick recap of what we covered in this video. We learned that finding an antiderivative just means that we're working backwards by thinking about what the original function would have been so that when we differentiate it, it becomes a current expression. And so far, we've just focused on the reverse power rule, which is adding 1 to the exponent and then dividing the term by that brand new exponent value. And remember, the general antiderivative is always going to require a plus c at the end, because any constant term is going to become 0 when we differentiate it. And of course, antiderivatives and derivatives aren't limited just to the power rule. We can reverse the process of all the simple derivatives that we've seen through the past 2 playlists. And some of the common ones are these trig functions, our exponential function, and then our log function. And now it is your turn to give this a try. Can you find the antiderivative of this function on the screen here? Don't forget to leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.